Okay, so good day class. So today we're going to discuss about the analytic study designs, no? And before we start, I need you to have your scientific calculator with you. Tapos if you have the copy of handout, okay din yon. Tapos, please prepare a one whole sheet of yellow paper and then you write kapag meron tayo mga problems dito, no? Mga cases, you need to compute with me. Tapos meron ding 3 cases dito or 3 problems na sasabihin ko na you may pause the video tapos you need to compute it on your own. Again, prepare your scientific calculator, tapos prepare a one whole sheet of yellow paper, tapos you write the solutions, no? Sulat nyo yung mga 2x2 table, tapos yung solution ng mga computation for the different cases that we're going to compute today, no? Both yung mga i-compute ko din, pati yung mga hindi ko rin i-compute. You need to compute on your own. Okay? So, now, let's start. And by the way pala, sorry, there will be certain topics na i-skip na natin, no? Because number 1, they are already discussed in our previous topics, and then number 2 is yung ibang mga topics dito are not that significant, especially in your level sa medtech course, no? Pang public health na sila, no? Tsaka statistician. So, dun muna tayo focus dun sa mga basic foundations of the analytic study designs. At saka yung mga basic computations. Okay? Now, so here are the learning outcomes. You can read it on your handout. Yan. First is the cross-sectional study. So, you may ask me, sir, di ba ang cross-sectional study design is also a descriptive study design? Bakit nandito siya sa analytic study design? So, basically, cross-sectional or yung prevalence studies, no? This can be used as a descriptive study design as well as a analytic study design because pwede ka makapag-generate ng hypothesis at the same time, you could also test that particular hypothesis. Okay? Bakit? Kasi, nung nag-generate ka ng hypothesis dito sa prevalence study, if you recall, no, sa measures of disease occurrence, nagkakaroon tayo ng a certain value. Diba? Nakakapag-compute ka. Okay? Tapos, yung mga computation na yon, yung mga prevalence proportion na yon, okay, pwede mo siyang i-solve further, no? In the what we call the measures of disease association. Okay? So, let's discuss that further later. So, cross-sectional study design, tatandaan nyo, the exposure and outcome are measured at a one point in time. So, these are the uses, no? Estimate the burden of disease or yung prevalence, establish a baseline data, and especially, no, a cross-sectional study design na analytic study design, it determines the association between coexisting variables. Okay? So, paano niya dinedetermine, no? So, before we proceed, pwede niya ma-determine yan positively associated, no? Or pwede ring negatively associated, or pwede ring not associated at all. Okay? So, later, makikita nyo yun. So, number 1, syempre, you need to know or you need to identify the target population or yung sample na gagamitin mo. Okay? And then, number 2, syempre, ano ba yung mga sampling techniques na ginawa nila. Okay? And then, number 3, you collect the data on the exposure. It's either the exposed, yung E, tapos yung unexposed or yung E, symbol E na may line sa taas. Okay? Next, you also collect the data ng mga disease. So, with and without the disease. So, disease, symbol letter D na malaki. Okay? And then, without the disease, D, tapos may line sa taas. Okay? Now, ito yung mga gagamitin nating measures of disease occurrence. So, we all know, yung prevalence ng population, yan yung kinompute natin during our midterms, no? Yung numerator mo, existing cases over yung total population. So, ganun lang yung kasimple. Dito naman, ito yung ko-compute natin for today. Yung prevalence among exposed, and then yung prevalence among unexposed. Okay? And another one, tatlo yan, we have also the measures of association. Ito na yung pinaka-importante. Kasi we can conclude an interpretation based on the computation of this prevalence ratio. Okay? This is your prevalence ratio. Okay, now, this is the first example. Again, prepare your one whole sheet of paper. You can compute it on your own, or pwede nyo ring sundan yung gagawin ko. Okay? So, first, cross-sectional study example 1. A sample of 5,891 randomly selected women were examined, and 201 were found to have breast cysts. So, the investigators wish to assess whether the use of oral contraceptive pills, or OCP, was associated with the prevalence of breast cysts. Among 3,247 OCP users, 124 had breast cysts. On the other hand, 2,644 non-users of OCP, 77 had breast cysts. So, the first step is gawa muna tayo, identify nyo ano yung mga exposure and ano yung disease. Okay? So, exposure natin dito, syempre, yung mga gumagamit ng oral contraceptive pills. So, yun yung exposure data natin, or variable. Yung mga unexposed, syempre, yung mga hindi gumagamit ng oral contraceptive pills. And then, ano yung disease? So, syempre, yung disease, yung mga magkakaroon ng breast cyst. Tapos, yung mga hindi nagkaroon ng breast cysts, sila yung without the disease. Okay? So, now, we create a 2x2 table. Okay? So, let's try exposed, unexposed. Disease, without the disease. So, sabi niya, ang 201 and 5891. So, 201 yung may breast cyst. So, lahat daw ng mga may sakit na to, ang total nila is 201. Yan. 5891 is yung total population ng lahat ng yan. So, 5891. Okay? Next. Among 3,247 OCP users. So, exposed or unexposed? So, sila yung mga exposed. So, meron tayong 3,247 OCP users. And then, 124 daw, disease or without the disease, had breast cysts. So, with the disease. Okay? On the other hand, 2,644 non-users. So, 2,644. 77 had breast cysts. Yan. So, ngayon, sir, paano natin makukuha yung mga data for the samples or yung mga individuals na hindi nagkaroon ng breast cysts? So, syempre, since ito yung total nila, no, ma-minus mo lang. So, 3,247 minus 124, 3, 1, 2, 3, that's 2,644 minus 77, 2,567. Okay? Tapos, hindi naman na importante yung data dito. So, pero kung gusto nyong i-compute yan, okay lang din. Ang answer dyan is 5,690 yata. Anyways, let's check if tama. So, ayan, no? This is present. So, this is yung breast cyst. Okay. Exposure natin, OCP. Okay. Tapos, yung sum. Yan. Total ng ito. And then, dito naman, total ng dalawang to. Okay. Tama ba? Same ba dun sa computation ninyo? Okay. So, next. Cross-sectional. Yan. So, compute na natin. No? So, alam nyo na to. Para ma-compute yung prevalence in the population, 201 over 5891. Di ba? Midterms lang yan. Yan. Okay. So, prevalence among exposed and prevalence among unexposed naman. Prevalence among exposed, ang i-divide mo, yan, PE is ito. Okay. Yung mga nagkaroon ng breast cyst na uminom ng OCP, 124, over yung total ng mga uminom ng OCP, 3247. Tas times the factor 100. Okay? Similarly, prevalence among unexposed, yung mga nagka-breast cyst na hindi uminom ng OCP, so 77, and total ng mga hindi uminom ng OCP, 2644 times 100. Okay? So this is your prevalence among the exposed, and then this is your prevalence among the unexposed. Okay, check natin. Ayun. So, tama. So, this is your midterm topic, no? Yan. Tapos, ito naman, prevalence among exposed. Yan. Times 100, 3.8. And then, this is your prevalence among unexposed. Okay? So, now, sir, paano naman natin ko-compute yung prevalence ratio? So, prevalence ratio, after you already computed for the prevalence among the exposed and then the prevalence among the unexposed, yung values na makukuha mo that you have already obtained, just divide them. So, for your prevalence ratio, prevalence among exposed over prevalence among unexposed. Okay? Ayun. So, 3.8 divided by 2.9 and the value is 1.3. Okay. So, take note nyo yan. Tapos na ba? Hindi pa. So, the last step is we need to interpret kung ano yung magiging yung nakuha yung value, ano yung magiging ibig sabihin nun. So, dito, titignan nyo lang to. Yan. So, for the interpretation of your prevalence ratio, if the value is less than 1, that means the exposure variable negatively associated with the outcome. Ibig sabihin, indirectly proportional sila. Pag tumataas yung exposure variable, bumababa yung disease occurrence. Pag bumababa yung exposure variable, tumataas yung disease occurrence. Ganun siya, no? Negatively associated. Kapag naman the prevalence ratio is equal to 1, no? Yun yung exact value niya, 1. Okay? That means that your exposure is not associated with the outcome. Ibig sabihin nun, walang kinalaman yung exposure variable doon sa outcome mo. Okay? And lastly, if the prevalence ratio is more than 1 or greater than 1, which is yung value na nakuha natin, 1.3, no? So, greater than 1 yun. That means the exposure variable is positively associated with the outcome. That means, if we're going to interpret this one, ibig sabihin nun, the exposure variable, which is the OCP use, is positively associated with the outcome, which is your breast cysts. No? Ibig sabihin, every time na gumagamit yung mga population ng OCP, no, mas tumataas din yung mga nagkakaroon ng breast cysts. Okay? So, ganun po ang prevalence ratio. Simple lang siya. Okay, so these are the advantages and disadvantages. So, pakibasa na lang, no? Baka lumabas sa major exam. So, pag sinabing attrition, yan, no? When we talk about attrition, that means it is the decreasing or yung varying number of sample size, no? hindi nagsasuffer ang cross-sectional because you have the actual number na ng data Hindi na pabago-bago, hindi siya dynamic like dun sa incidence. Di ba? If you recall that. Meron ka ng exact value to compute. So, it does not suffer from attrition. Okay? So, ayan. Next is the cohort study. So, cohort is a group whose members share a distinct set of characteristics followed up within a specific period of time. Okay? Ibig sabihin, meron ka ng follow-up period from this point. No? So, exposure is measured at the present time and the participants are followed up to measure the outcome at a future time. So, this is your regular prospective prospective cohort study. And then, this is your retrospective cohort study naman. The exposure is in the past is measured and the participants are followed up to measure the outcome in the recent past. Okay? So yan yung difference nila. Retrospective, nangyari yung exposure, magpa-follow up ka ng outcome. Okay? Yung retrospective pala. Retrospective, nangyari na yung exposure noon, no? Tapos, check mo na lang outcome sa recent times, no? And then, pag prospective, exposed sila ngayon, tapos follow up ka in the future kung ano yung magiging outcome nila. Okay? Ayan. So, these are the uses of your cohort study. Calculate the risk of the developing the disease. Establish the temporal relationship between the study variables, and expedient in examining the multiple outcomes, and practical in studying rare exposures. Okay, so ito yung mga gagamitin natin which were discussed nung midterms: incidence proportion and incidence rates. No? Incidence proportion kapag yung mga sample mo ay fixed populations. Incidence rate naman kapag they are dynamic. So, nandito yung mga person time. Okay? So, ito naman yung mga bago nating malalaman ngayon. Risk ratio and rate ratio. Okay? So, this is the incidence proportion. Tinuro na natin to no midterms. Yan. Okay na yan. So, incidence rate naman, yan tinuro na rin yan no midterms. New cases, tas person time. Yan. Okay. So, relative risk. So, relative risk can either be risk ratio or rate ratio. It is risk ratio if you're trying to compare for incidence proportions. No? And then, it is rate ratio naman kapag if you're comparing incident rates. So, what's the difference between the two? Wala naman. In their computation, same lang, no? Incidence among exposed and incidence among unexposed. 'Di ba? So, napakadali lang, no? Kamukhang-kamukha lang ni prevalence. The difference is kung paano natin makukuha tong mga value to. Okay? And, syempre, magdedepende rin yan if yung incidence mo is proportion ba or incidence rate. No? Tandaan nyo, pag proportion, fixed. Pag rate, dynamic population. Dynamic population, paiba-iba. Ibig sabihin, person time. Fixed population, ibig sabihin, iisa lang yung value nila from starting point hanggang end point. Okay? Okay, gets. So, pag incidence proportion na fixed, risk ratio tayo. Kapag incidence rate na dynamic, that is your rate ratio. Okay, so again, ganito lang mag-interpret, no? Less than 1, exposure variable is a protective factor. equal to 1, exposure has no effect on outcome. Pag naman greater than 1, that means exposure variable is a risk factor. Okay? So, papansin nyo kung gaano siya ka-importante, no? Pag less than 1, protective siya. Pag greater than 1, risk factor na siya, no? So, let's try. Okay, this one. So, data on diarrhea during a 10-day follow-up period among 30 breastfed infants colonized with the Vibrio cholerae 01 subtype according to their anti-lipopolysaccharide antibody titers in the mother's breast milk. Okay? So, ayan, meron na tayong table. Ito yung nakuha nilang results. So, for the patients na nagka-diarrhea, the high antibody level is 7. Yung mga walang diarrhea, high antibody level, 9. Mga nagka-diarrhea, 12. No diarrhea, 2. Okay. Now, since meron na tayong table, we just need to identify what is our disease outcome at saka ano yung exposure. So, as you can see, they are colonized with a Vibrio cholera. Ibig sabihin, binigyan daw sila ng vaccine, no? This is an attenuated version na ng bacteria na Vibrio, no? Attenuated means pinahina na yung bacteria na yan, so pwede na siyang gamitin as a vaccine. Okay? So, that means yung ating exposure is kung ano yung result ng vaccine na yon. So, yung mga exposed would be the high antibody level. So, papansin nyo medyo baliktad siya. Okay? So, high antibody level, this is the exposed. And then, low antibody level naman ngayon would be the unexposed. Okay? So, syempre, diarrhea is yung mga disease. And then, no diarrhea, yung mga no disease. Okay? Tapos, okay? So, now, we need to identify, is this an incidence proportion or incidence rate? No? Ngayon, titignan muna natin kung nagbago ba yung mga total number of your yung sample mo. No? So, 19, tas 11, so 30. So, nag-start sila ng 30, after 10 days, dapat 30 pa din. So, 30 pa din, ibig sabihin, di nagbago. Fixed yung population mo. Okay? So, this is incidence proportion. And since this is incidence proportion, ang magiging computation natin for the measures of disease association is risk ratio. No? Risk. Okay. So, now, let's try to compute. So, 7 plus 9, 16. And then, 12 plus 2, 14. Okay? So, ito, pwede nyo rin naman na baliktarin na yan, no? Na yung exposure variable nyo nandito sa kabila. Tapos sa taas yung disease, no? As long as na so, ganito yan siya. So, okay lang din yan para hindi kayo nalilito, no? Minsan kasi pabago-bago yung pwesto ng exposure tsaka ng disease, no? So, wag kayong papalito in terms of that. Okay? So, ayan, 12, 2. Tapos, 14. Okay? Ayan. So, ano sabi kanina? Sabi, you need to compute the incidence among exposed and then incidence among unexposed. So, paano natin ko-compute yun? So, syempre, compute mo lang 7 among exposed, among exposed, divided by 16. Yun na yun. Yun na yung makukuha mong value. Yun na yung incidence among exposed. Tapos, incidence among unexposed, 12 divided by 14. So, yun na yung incidence among unexposed. Okay? So, check natin. So, this is an stata, no? So, pwede nyo ring itry yan sa SPSS or sa Excel, no? Yung ganitong computation. So, 7 divided by 9. Ito. 7 divided by 16. You will get this particular value. Okay. And then 12 divided by 14. Ito yung makukuha mong incidence among unexposed. So, incidence among exposed, incidence among unexposed. So, again, divide mo lang yan, incidence among exposed. So, 0.4375 divided by 0.8571429. Napakadami, no? And then, makukuha mong risk ratio would be this one. 0.5104167. So, basically, the result is less than or greater than 1 or equal to 1. So, the answer is, it is less than 1. No? So, if the value is 0.51, yeah, pwede na yan. It is less than 1, ibig sabihin, the exposure variable is a protective one. No? Ibig sabihin daw, itong vaccine, no, na Vibrio cholera 1 na attenuated, okay, it is a protective variable against diarrhea. Okay, so ayan, this is another example. So ito naman, this is a data on breast cancer cases and person years. So yun, nasa case na, no? Person years of observation for women with tuberculosis repeatedly exposed to multiple X-ray fluoroscopies and those not so exposed. Okay? So, ito, as you can see, meron na tayong mga exact value. No? So, exposed daw to X-ray. So, ito yan, exposed. And not so exposed. Ayan na yun. So, in this case, ito yung disease mo. And then, ito person years siya. So, sinabi niya person years. So, matik na. Alam nyo na that the computation would be, the population is dynamic. So, this is incidence rate. Dynamic. And since it is dynamic and incidence rate, ang gagamitin natin is rate ratio. Okay? So, paano kino-compute yan? So, madali lang. Apin na to. No? Hindi mo na kailangan minus yan or plus. 41 divided by 28,010. 15 divided by 1917. Yun na yung incidence rate mo among exposed. And then, yun na yung magiging incidence rate mo among unexposed. Yan. Na yun. Diba? So, 41 divided by 28010 and then 15 divided by 19017. Okay? So, ito na yung incidence rate mo among exposed. And then, this is the incidence rate among unexposed. So, once again, divide mo lang yung nakuha mong value, incidence rate among exposed, 0.014,638 over yung nakuha mong value ng incidence among unexposed, 0.000738. So, makukuha mo dyan is 1.855759. So, as you can see, the the sorry, the rate ratio or yung relative risk mo, yung rate ratio mo is 1.855. Ibig sabihin, it is greater than 1. Okay? It's more than 1. So, the interpretation is the exposure variable is a risk factor. Ibig sabihin, yung repeatedly exposure to X-ray fluoroscopy could cause or is a risk factor for breast cancer. Okay? So, ganun lang siya kasimple. So, here are the advantages and disadvantages of your cohort study. Okay, so ayan. So, ito yung sinasabi kong exercise. So, you may pause the video so you can compute it on your own, or you can just look on your copy, no, ng ating PowerPoint presentation. So, you need to compute this on your own. Mas maganda on your own para at least you could practice. Okay? Okay, next. So, next is the case control study. So, case control study naman, the outcome is measured at the present time, and then yung exposure of the participants is in the past is estimated. Okay? So, ano ba yung gamit nito? So, determine the association between variables, syempre, because this is a analytic study design, and then estimate the relative risk. Then, expedient in examining multiple exposures, and practical in studying rare diseases. So, case control studies, wala siyang measures of disease occurrence. So, lahat na makikita nyo dito is bago, pero napakadali lang naman i-compute ng mga yan. So, exposure odds and odds ratio. So, pag sinabing odds, it is the probability of an event happening over the probability of an event not happening. Pag exposure odds, probability of having the exposure over the probability of not having the exposure. So, ayan. Exposure odds among cases, no? And then, exposure odds among controls. Okay? Yan. Basahin nyo na lang kasi ulit-ulit lang naman siya. Yan. So, again, this is the interpretation for your odds ratio. So, odds ratio, ayan. Yung sa taas, that is your exposure among cases. Ito yan, among cases. And then sa baba, among controls. Okay? So, pag the value is less than 1, the exposure variable is a protective factor. So, similar lang siya dun sa kanina. The odds ratio is equal to 1, no effect on outcome. And then, if it is greater than 1, exposure variable is a risk factor. Okay? Okay, yan. Let's try this one. Data on the history of chlordiazepoxide use in early pregnancy for mothers of children born with and without the congenital heart defects. So, ang case mothers would be your D. Tapos, yung control mothers will be your without the disease. Okay? Exposure mo, syempre, yung use of this particular gamot na mahirap bigkasin. And then, syempre, unexposed yung hindi gumamit ng gamot na mahirap bigkasin. Okay? So, ayan. Okay? Compute na tayo. Let's go. Okay? So, ito 400. And then, ito is 1254. Okay. So, compute nyo muna yung yung sa taas. Okay? Yung ito. Exposure odds among cases. Okay? So, exposure odds among cases 4 over 400. No? Ito. 4 divided by 400. Tapos, odds among the controls, 4 divided by 1254. Sir, paano ko nakuha yung 400 and 1254? So, ang gagawin mo lang, add mo lang yung 4 plus 386. So, yan yung total dito. Total ng mga cases, no? Tapos ito, total ng mga controls. Okay? So, makukuha mo na lang yung value ng exposure odds among your cases. Ito. And then, exposure odds among your controls. Okay? Excuse. So, paano mo yan makukuha yung odds ratio? So, odds ratio, syempre, ano yung makukuha mong value dito? Next slide. Ayan. So, ayan. Ito. 4 divided by 390 pala yun. Ba't 400 ginawa ko? Sorry. 390 pala. Oo nga, hina sa math. Madaling araw na kasi. Ayan, 390. Ayan. 4 divided by 390, you get a 0.013. 103. So, yan yung odds among the cases. Tapos, exposure odds among controls, 4 divided by 1254, you will get a 0.0032. So, odds among controls, yun. Then, divide mo lang yan, and you will get this one. 3.2383. Pwede na yan. Okay? Or 3.24. Pwede na yun. Okay? So, anong ibig sabihin nun? Ibig sabihin, the odds ratio is greater than 1. Okay? So, we go back. If it is greater than 1, it is a risk factor. And napakalaki niya kasi 3 na yung value na. No? Ibig sabihin, itong gamot na to is a risk factor for development of congenital heart defects ng mga anak nila. Okay, so kung risk factor yan, kailangan i-avoid yan ng mga pregnant women. Okay, so these are the advantages and disadvantages ng case control. Okay, pakibasa, baka lumabas sa exam. And then this one naman is a case control study exercise na kailangan nyong sagutin on your own. Okay? So, you may pause the video, tapos you try to compute this on your own. Okay? Okay? So, kung nakuha nyo na yan, actually, nandito yung sagot dyan. Okay, ayan. So, 24, 39, 63, 6, 22, 28. So, paano siya ino-compute? Again, ayan. Exposure odds among cases, 24 divided by 6. And then, 39 divided by 22. Ayan. And then, we have also another technique na pwede nyo ring gamitin when computing for the odds ratio, no, ng mas mabilisan. So, paano yun? Ito, cross product ratio lang. Yung value ng exposure na nagkasakit over sa value, no, ayan, multiply mo lang yan, 24 multiplied by 22, 528, tapos 6 times 39, okay, 234. Makukuha mo rin is a same answer. Ayun, diba? So, this is another technique that you can use kung magmamadali kayo. Shortcut method yan. No? As long as tama yung placing ng exposure and ng disease. Okay? Ayan, next. Ito na pala talaga. Yan. Yan, for real na to. So, you may pause the video and then try to compute this on your own. Okay? Okay. So next and lastly is the experimental study. So experimental study is a cohort only with assignment manipulation of your exposure. Meron din tayong tinatawag na randomization, pero itong randomization di na nasyadong i-compute yan. Okay. So this experimental study is the best study design for controlling the confounders or yung tinatawag nating third variable. No? Kasi you can manipulate that particular variable as a researcher. So this study design provides the strongest causal inference. Okay, so this is randomization. Yan, di ko tatanong yan sa exam. So, okay na yan. Yan. So, ito yung mga gagamitin natin. So, similar lang dun sa risk ratio and rate ratio. Lalabas dito is incidence proportions and incidence rate. Tapos, very similarly, yun din yung gagamitin natin. Risk ratio and rate ratio. Okay? However, to compute for the experimental study treatment effect, okay, ganito mo siya ko-compute. So, nagmamadali ka, ganito lang. 1 minus the relative risk or yung 1 minus the rate ratio or 1 minus the risk ratio. Pero this is the best method. Okay? The incidence of control minus the incidence of the intervention over the incidence of control. Okay. So, issues. Ayan. Pakibasa na lang. Ayan. Okay, let's try this one. So, experimental study exercise 1. It has long been suspected that diet has a role in the causation of neural tube defects, one of the commonest severe congenital malformations. The possibility that supplementation with folic acid might reduce the risks was given credence by the results of 2 intervention studies, both of which had methodological weaknesses. A large randomized control trial was needed to resolve the matter. The trial was conducted in 33 centers in 7 countries amongst women known to be at higher risk through having had a previous affected pregnancy. They were allocated at random 2 groups who received supplementation with folic acid or none. Of 27 babies born to these women with neural tube defect, 6 were in the group of 593 mothers who received folic acid and supplementation, and 21 in the other group of 602 mothers and in the other group. Okay? So, let's try to compute. Ayan, ganyan. Shortcut na natin, ha? So, ito na yung disease mo. 6. Ayan, 6. And then, 587. 593. Okay. Paano kasi nakuha yan? Ayan, 27. Learn to this women, neural tube defect. Ayan, 6. Ayan, 6. Tapos yung 21, ayan, 21. Tapos 593, ito yan. And then 602, ito yan. Okay? Tapos syempre, minus mo lang yun. Kuha mo na yan. Okay? Now, paano mo kukompute yung incidence among intervention and incidence among control? So, incidence among intervention is ito. 6 divided by ito. Yung total. 593. Okay? Siyempre, incidence among control, 21 divided by 602. Okay? So, what's the answer? Ayan. 1.01% and 3.49%. So, bakit percent? Minultiply pa yan by factor of 100. Okay? So, yan. 1.01 and 3.49. So, relative risk, divide, tapos meron ka ng relative risk value. So, yung treatment effect, ito na yan. Yan. So, yung CIC minus CI1, so 349, yung IC yan, no? Minus yung intervention, 1.01, ito. Okay? So, 3.49% minus 1.01 over 3.49. Kuha mo is 0.71 or 71% treatment effect. Okay? Ibig sabihin, yung intervention nila, which is yung folic acid, okay, 71% yung kanyang effect na makapag-prevent ng neural tube defects. Okay? Tapos, kung babalikan din natin, yung incidence naman na yan, 0.29, di ba? Okay? Protective factor siya, ibig sabihin. So, ano siya, di ba? What you call this? Magkatuloy naman sila, di ba? Na protective factor yung folic acid. Tapos dito naman, sinasabi niya na yan, ganyan yung epekto ng folic acid. No? Nakakatulong siya 71% of the time. Okay? So, ayan. So, this one naman, you need to compute this on your own. Again, I think this is the last one, no? So, pause the video and then you need to compute this on your own. Okay? So, that's it. Ay, last na lang pala. Sorry. So, this is the last slide, no? So, these are the classifications of your experimental study. So, clinical trial, intervention is allocated to individuals, no? Isa-isa. Pag community, syempre sa pangalan niya na community, intervention is allocated to an entire community. Pag therapeutic, the intervention is a treatment agent. Ibig sabihin, nagkasakit na yung mga gusto mong tulungan. So, therapeutic trial na yun. Pag prophylactic naman, prophylactic trial, intervention is preventive agent. Ibig sabihin, yung mga population mo, at risk sila, wala pang sakit, no? Pero at risk sila, so kailangan mong bigyan ng gamot, no? To prevent that particular disease. Okay? Parallel design is the between subjects, and then crossover is within the subjects design. Okay? Focus lang kayo dito sa mga to. Okay? And that's it. So once again, if you have any questions, just email me. No? Especially if any of those particular computations is medyo mahirap, no? You can contact me. Okay? So, email nyo lang ako. Okay? So, thank you and God bless. Stay hydrated, no? Kailangan lagi kayong uminom ng tubig, lalo na't mainit ngayon. Okay? So, again, thank you. And then, submit nyo na lang yung mga one whole sheet of paper once we meet sa next face-to-face meeting. Tapos, prepare for an exam. Ay, quiz. Okay? Goodbye.